Let's now change our data type to PLS integer. Now I'm deleting the data type number and changing it with PLS integer. We need to delete the precision and the scale parts of data type declaration and the decimal parts of our number value, because it's an integer data type. No decimals for this data type. Since this is faster than number data type in performance, I recommend you to use this data type instead of number data type if you are going to use integers. Since this is a very simple code, it's hard to show you the difference in performance. So I'm deleting in here and here. But when you are dealing with a costly code, you will see the difference. Let's now execute it. As we can see, no problem. Let's now delete PLS and write binary integer. As we can see, no problem. Now let's change our number to binary float and change our variable to 50.42 again. The difference in here is we cannot assign precision and scales for binary float and binary double. We just need to write F for binary float and D for binary double right after the number. As we can see, the number is scientific type and not accurate. These data types are faster than number data type and needs less storage, but you need to be careful that if you need to calculate accurately, you should avoid using binary float and binary double data types. These data types are for scientific calculations where accuracy is not so important. Otherwise, you should use number data type. It encapsulates these data types. I mean larger than these, but slower and needs more storage. Alright, this is enough for number data type. There are a lot of number data types or subtypes. You can check from Oracle's documentation and try if you wish. But these are the ones that you will mostly use. Now let's pass to the date time. Let's start with date data type. So let's change our name with vDate and the data type with date. And the initial parameter is sysdate. As we know, sysdate returns the time of now. Let's change the name in dbms output and run the code. It has shown with just days, month, and years. But this is because our settings in SQL Developer. Let's change it and see the actual time. Now let's go to Tools, Preferences, and Database, and NLS. And now we need to add our hours, minutes, and seconds. HH24 for 24 hours, and MI, and comma again, and SS for the seconds. Now let's say OK, and turn back to our code and run it. As we can see, now we have the details. Or we can assign a value to it. Let's delete sysdate and add our value. 22 November and 18, for example. Now we have the date but not the hours, minutes, and seconds. So let's add it with 14 and let's say 01 and let's say 32. We can either assign a value or get it from the function like we used in sysdate. Now let's change the date with timestamp and change the initial value. Let's change it with systimestamp. Because systimestamp returns the timestamp of now. Let's run it. Now we have a more detailed date which has some more fractions and milliseconds. If you need something so, you can use timestamp data type. Let's add with time zone keywords after timestamp and run it. As we can see, now we have the time with the local time zone. It is +3 for our country. Let me explain you something while I remembered. All the timestamp data types has precision. So we can write 3, for example, in here. This is a precision of timestamp keyword. Only 3 digits of fraction in milliseconds are returned. You can assign this precision between 1 to 9, or you can omit it. When you omit it, the default value will be 6. As we can see in here is 6, the default value, and we assigned it 3, and in here we saw just 3 digits. Now the next 2 data types that I will explain to you is interval types. We have an interval day to second and interval year to month data types. These data types are for measuring how many days and seconds passed. For example, you can say that 122 days and 2 hours, 5 minutes and 10 seconds passed after the first day, for example, you enter to your job. Or you can say that 10 years and 5 days, like in the first one. Let me show you how to use them. Let's start with the interval day to second first. We simply write interval in here, and then day, and 4 for the maximum value, then 2 seconds, and 2 for the maximum value of millisecond fraction. And it's equal to, let's say, 24 space and 02, for example, and comma sign. These are separated with comma signs, and 05 and 21 and 012, for example, for the fraction. We just put a space between day and hour and a dot sign for fraction of millisecond. Let's run it. Plus 0024 for date, and the rest is sequential hour, minute, second, and millisecond. 0 before the day value is for that we set 4 for day in our declaration, and 2 for milliseconds is for that we selected 2 for our millisecond fraction. The precision limit is 1 to 9 for both of them. The default values are 2 for day and 6 for millisecond. Now let's see how to use interval year to month. We simply change our variable declaration with interval year to month. And it's equal to, let's say, 12-3. Let's run it. We can see that plus 12-03. It's plus because you can select minus if you wish in the assignment. We cannot specify a precision for month. It's 2 by default, but we can specify a precision for year. It is 2 by default, but we can change it. Let's change our value with 122-3. When we run it, we had an error because the default is 2. So let's add its precision with 3 now. Let's run it. No problem. You can specify 1 to 9 for precision, or you can omit it. Will you use interval year to month or interval day to second? Not really. It's a very low possibility. But I try to explain as if you need somewhere. So the last data type I want to show you how to use it is Boolean data type. Let's change our name with vbool first. And the data type is Boolean. And the initial value is, let's say, true. Before running, let me clear here. Now I need to change the dbms output part. and run it. We can see that we had an error because we cannot use boolean as printable. We can use it in if statements, for example. We will show that in the next lessons. This is for how we create and initialize boolean values. So this is the end of declaring, initializing, and using variables lesson. See you in the next lessons.